Okay, welcome everyone. This is the 27th Vienna Digital Identity Meetup. It is the first one of what will be a series of meetups around IoT and identity that will be coming up between over the next few months. Today, we will be having Dr. Xinxin Fan from IoTeX will be presenting on decentralized IAM for IoT and some of the challenges and opportunities. So before we get started, there'll be a few things that we'll cover. One is as Xinxin is speaking, either put your questions in the chat, and as we go through it, either you can, I don't know, Xinxin, do you mind if people just call out their questions, or do you prefer them being put into the chat, or do you want to hold their questions? How would you like to proceed?
Yeah, I think either way should be fine.
Okay, thank you. So Vienna Digital Identity Meetup is coming up to its third anniversary, which will be in January of next year. The purpose of the meetup is to educate both business and technologists on the value of high assurance digital identity in business and society. We vary the presentations between more technical and more business orientation. Today is one that's going to probably line more on the technical side, but the purpose is to not only enable the technologists and the engineers to understand the different technologies, particularly around the decentralized space, but also those that are on the business side to understand why this is of value, why this is important, and being able to articulate the business value, which as a former hardcore engineer, but probably more on the business side now myself, it's important to be able to articulate what the business values are of technologies versus just something neat and new, which then helps people then understand why it's important and why it should be something that is adopted or something they should be keeping an eye on. So decentralized identity access management, I think we're all, people who are on this call or typical participants are familiar with the IAM, which exists in our organizations today, whether it's centralized inside the firewalls of a company or it's a hosted service by Azure or AWS or Google. The usual model for identity access management has been around the individual, around members of an organization having access, authentication, authorization to different resources within a business. IoT is pushing the boundaries just due to the scales and the volumes, and the concept of a decentralized IoT or decentralized IAM is something that is quite new on the landscape, driven, I think, also with the rest of the decentralized Web3 world. This is how Xinxin and I first connected, was around this area of decentralized IAM in a paper that he had written. And I thought this would be a good conversation to share with the community on where the value is coming from and some of the technical details. So Dr. Fan is also leading one of the co-chairs for an IEEE working group around decentralized IAM, as well as being the head of cryptography for IoTeX. So without further ado, Xinxin, I will turn it over to you.
Yeah, thanks for the introduction.
Okay.
Let me share my screen. Right. Yes, thanks for the invitation from Michael for me to giving this presentation. And nice to meet everyone from the identity community. Yeah, today I'm going to talk about the decentralized IAM for the IoT and share with you guys about some potential challenges and opportunities. All right, before the introduction, before talking about the IAM, give you a very brief introduction about myself. I'm currently the head of cryptography at IoTeX. IoTeX is a Silicon Valley startup focusing on building on the next generation blockchain platform for the Internet of Trust things. I'm also the co-chair for the industrial IoT consortium for the industrial distributed ledger task group, involving leading two standardization working group within IEEE. One is 2418.1, which more focusing on the blockchain use case in the IoT case. Another one is 2958, which is more focusing on the identity and access management for IoT. Yeah, I'm also involving some other activities in confidential computing consortium to accelerate the adoption of this technology, as well as the Trust Trip initiative in Mobi, for applying the DID and VC to the automotive use cases. This will be the outline for today's talk. I will first talk about the IAM for the IoT case, talking about the centralized version versus decentralized version. Following by that, I will talk about some challenges when you consider that applying the decentralized concept to the IoT use case. Also point out some potential new opportunities for building a decentralized version for the IAM. Yeah, after that, I will briefly overview about this IEEE P2958 standards projects. Finally, give you a brief introduction about the Internet of Trust Things platform or IoTC platform. That is some initiative on the IoTeX. Try to push the decentralized version for IAM to the market. All right. Yeah. Firstly, let's take a look about the IAM for IoT. Right. So, this is a cloud native IoT system architecture. Yeah, we have been using today in almost every IoT applications. Right. So, on the left side, you can see that's basically cover almost every IoT implementation structure we have been experienced today. You have the the smaller IoT device or a little bit powerful one, which will be connected to the cloud IoT gateway, right? So then everything will be running on the cloud. You have a number of core services like the user management, for device management, storage, digital twin, etc. Building upon those core services, you can develop all kinds of applications. So everything will be running on the cloud to build the different type of applications. Then user will use their mobile device or the laptop or other device to access the cloud service and to control their device. Right. So typical cloud provider we are all familiar with: Microsoft, Google, IBM, etc. Right. So from this figure you can see this is like the cloud-centric design for almost every IoT applications, and this is quite clear. Like who has captured the most value in this entire value chain. Right. So, but today's talk will more focus on the identity aspect, which means we will discuss more for those two components within the this red rectangle. One is user management, it's the device management. Okay. Yeah. So in terms of the user management, actually take the AWS example, right? So they differentiate between between identities and permissions, right? So essentially, they give you a number of ways to create the like the user group, or you can create a different roles and create a different credentials. So those will give you the like the different permissions when you try to access the resource within the entire application, right? So those permissions will be written in terms of statements, and then they can you can have all kinds of combinations of roles, groups, or the users. Then you can have the different combinations of those different pieces of identity to determine who can access what, right? So this is almost all the cloud providers, how they handle the IAM aspect, right? You have the number of users, you assign them to the different group or assign them to the different roles. Then depending on the group or roles, you write statements, then you define how they can access the resource in your network. Okay, but IoT has also has the other aspect that will be the device management. So from the cloud perspective, the user management on your cloud backend, you need to define all of these different type of identities, roles, and permissions. So from the user perspective, that's what we we usually experience when we use the smart device applications, right? So you will either see the centralized identity solutions, that's the username password, when you try to access your smart home, for example, or you will see the federated identity solutions when you try to log into your smart home application. So those from the user perspective, you will see those two common patterns when you use your smartphone to access the IoT application. Okay. Those are about the user aspect of IAM. How about the device aspect, right? So let's look again about the AWS IoT, right? So the idea here is quite simple, right? If you have something is outside of your application domain or outside of your system, how can you bring it to into your system as a part of the components? The idea is to create a digital twin, right? So the usually practice is that you install a cloud SDK onto your smart device. Then this device on the cloud side, you can create a digital twin to represent this device in the physical world, right? So this digital twin basically capture all the metadata or status of the physical counterpart, and you can control this digital twin through other cloud services. So this basically give you a mapping from the physical world to your digital domain. So after this digital twin is created, here like this figure describes the device shadow. It's a similar concept. After this one is being created, eventually you have a components within the cloud service boundary. Then you can define all kinds of access policy, or the authorization, or you can do all kinds of authorization or authentication services through this digital twin. User also can control this digital twin to send the command as a result, the device can be controlled in the physical world. So this is how all the cloud service provider deal with device management, right? So once they create a digital twin, and this digital twin will be blend into your cloud service like other components you created, then you can operate that like the other services. Okay, this is a very nice idea. How they bring the device or something the physical world into their digital domain. Okay. Then yeah, every device related services like device registry, device gateway, and the other yeah, storage and other services all can be running.
Did we lose you? Xinxin, I don't think we can hear you. Oh, we will pause the recording for a moment. Wait, resume the recording.
Yeah, I think let's continue. Yeah, we can start from here. Yeah, essentially.
You want to reshare your screen because it's not, the share is not coming through.
Okay. Yeah. Let me share my screen. All right. Yeah, I think we can.
Yeah, we were just. What's the previous slide?
Yeah, previous.
Yeah, you were just. I think you're just finishing off that slide. Yeah. When you
Okay.
got. Yep. Okay.
Yes. So yeah, we can start from here. So essentially, you need to create a set of private and public key and the corresponding certificate and download all of those credentials into your device. So in this way, your device can connect to the like cloud gateway. Then so on the cloud perspective, they can identify your device by the certificate you download there. Yeah, in this way they can know who is connected to the cloud service. Okay, the certificate here you can see is a X509 certificate we are familiar with. So this one is solely be using to identify the device and to establish the TLS connection. Okay, from here we can see this basically how the cloud service provider, how they deal with people's identity and the device identity. Yeah.
So a question here, Xinxin. So in this case, is it a unique X509 certificate per device, or is it the same device certificate used across multiple devices? Typically?
Yeah, it's typically it's a different certificate for per certificate per device.
Okay.
So yeah, in this way, each device has a separate TLS connection with the cloud backend.
Okay.
You don't need to worry about your data being eavesdropped by other device. Yeah.
And so are you your own CA then within an organization, for example, would be their own?
Yeah. So
okay.
Cloud service provider, they provide you multiple options, right? So either you can use their CA as a root, like shown in this figure. Besides those certificates, you need to also download root CA from the AWS. Then in this case, you use AWS as a root certificate for establishing this secure connection. Other option they provide to you is that you can upload your own certificate root. Yeah, in that case, you can issue a certificate based on your own root and download to the device. Yeah.
Okay, thank you.
Yeah, it's just multiple options you can take advantage of the PKI within the cloud environment. Okay. Yeah, so here we already see how the cloud service provider, they handle the people's identity as well as the device identity. Okay. Yeah. In the centralized IAM solutions, like I discussed before, when you have the two entities, one is a service requester, the other is a service provider. When these two entities want to interact, this is like the typical step. I did a lot of extraction here. Try to explain what's going on in the general process, right? So service requester, they will first request a service from the service provider. Then service provider say, okay, in order to I know who is trying to access my service, but you need to show me you have the correct permission to access this service. So they will request an access token from this requester. Then the requester need to talk with centralized IAM server or its authentication server within the like the cloud boundary. They need to authenticate with IAM, centralized IAM server, because they know all the users and they know all the permissions, right? So it's also managed by the centralized service. So after successfully authenticate with IAM server in the cloud, the cloud side they will grant access token. Then the service requester will send this token to the service provider and get access. So this typically how a centralized IAM system work when two entities, either people or device, they need to interact with each other. Okay. Yeah, if we do it in a decentralized way, right? So since everybody here are familiar with DID and VC, I will skip that part for the introduction. The access flow is a little bit different, right? So service requester, they still want to request a service from the provider. On this side, the service provider will look up like the trusted data registry. It can be the blockchain or other decentralized infrastructure to see, okay, who is behind this state, right? So they will retrieve the document to resolve the document to see where I can get more information about this requester. Right? So then they instead of request a access token, the provider will say, okay, show me your verifiable credentials in order to access this service. Also, they may need multiple verifiable credentials in order to grant access. On the requester side, they will put everything together to generate a verifiable presentation. After the validation from the service provider, they will grant a service access. Okay, this is just the different way to implement the when two entities want to interact within using the IAM. Okay, you can clearly see the advantage and the disadvantage here. Right, so for the centralized version, definitely everything is controlled by the centralized IAM. It's a single point of failure, of course. And when you have a lot of interactions, like in the IoT scale, this centralized server also has a scalability issues. Right, so that's a main disadvantages for the centralized solution. Decentralized solution, you need a read from the trusted data registry, to check who is access. Everything else, if you trust the verifiable credential issuer, everything else is quite clear and straightforward. You can just validate the verifiable presentation, then to grant a service. So everyone can do this asynchronously, without rely on the centralized without relying on centralized server. Okay. After talking about the centralized versus decentralized, a key question here is that what do DID and VC? Why do the DID and VC matter for the for IoT, right? So why we need to consider the DID and VC for the IoT use case? From the cloud perspective, we already see they manage the user and the device separately, right? So you have a separate the service for managing all the users, their roles, their groups, and their identities, right? So device management is another service. So those two, although they both manage the identity, but they are separate services, right? So the first advantage when we consider the DIDs in this case is that DID offer a unified representation of identity for everything, right? So people, IoT device, server, organizations, etc. So essentially, you can combine these two pieces together to give a universal representation for identity. Whatever it's a person or it's a device. Therefore, you can simplify the identity management and ensure the interoperability. Yeah, you don't need to have a separate service for managing the people and the device, right? So they all follow the similar pattern for the identifier, and they can also seamlessly interact. Yeah, this is what's actually what's the ID bring to the IoT ecosystem. How about the VCs, right? So VCs enable you to attest the identity attributes, right? So essentially, in the IoT ecosystem, the very important features VC can bring in is that VC actually enable the stakeholders of the IoT ecosystem to attest different attributes regarding the IoT device. For example, the manufacturer can issue a VC said, okay, this is a configuration for my device. This is a particular MCU I'm using, also equipped with a TPM, for example. So, and this is a operating system currently running on my device. Up to the certain version, right? So all those information will give the user more insight regarding the security and trustworthiness of this device, right? So when you try to bring on a number of IoT devices into your, for example, your enterprise network, based on those information, you can have more fine-grained level of control in terms of the security and trustworthiness. Yeah. So from this perspective, VC bring a lot of advantage for you to design fine-grained access control. Yeah, based on the VC provided from the different stakeholders. Yeah, last but not least, when combining the DID and VC together, it's possible to build a large-scale, decentralized, and interoperable IoT applications. So the existing applications we are experiencing today is all isolated, right? So you have the IoT applications for the just for the single purpose. When you see your smartphone, they have the different app for control the different systems. It's really hard for them to talk together today. But VC, DID and VC can really help in this aspect. So since everyone, every device or everything will follow the similar identity representation, and they can exchange information and value smoothly. Those are the I think that those are three important values DID and VC can bring to the IoT ecosystem. However, when you consider applying those new concepts into the IoT ecosystem to create a decentralized version of IAM, there are still a lot of challenges. So next, I will talk about the challenges and the potential opportunities for the identity community. yeah, challenge number one, yeah, unlike the one we deal with the DID and VC for people, right? So most applications will be used, will be deployed on your smartphone, right? So like your identity wallet and all the VCs, all the credentials will be all stored in your smartphone. You do not have many resource constraints. You need to be care too much. Then everything will be the wallet and agent will be all implemented on your smartphone. So for the IoT case, for other embedded system case, you will need to handle more complex situation, right? The reason that there's a wide range of IoT devices with different capabilities. Yeah, from very smaller one like the small thermostat or the light bulb, yeah, to the medium IoT device like those device running 32-bit microcontroller like your smartwatch, and other other like small tracker, etc.
Xinxin, there's a question in the chat.
Yes.
Diego said, you mentioned the IoT gateway. How do the decentralized architecture map then? Do you have different levels of security, for example, between IoT gateway and then gateway to cloud?
Yeah, so in the decentralized case, you can your IoT gateway you need to be run in a decentralized manner, right? So you need to have the gateway to understand the different communication protocols between the IoT device and the gateway. Of course, depending on the capability of your gateway, you may only be able to talk a certain amount of IoT devices, right? So if you only understand, can support the MQTT or the CoAP protocol, you only can talk with those smaller devices to bring them into a digital world. In terms of the mapping, actually you need to in the decentralized architecture you need to record who is in the system on the blockchain, right? So you do not have a cloud backend anymore. You may still you may still want to have a hybrid architecture in some use case, but if we only consider the IAM case, essentially you need to keep that mapping on the decentralized infrastructure, for example, on the blockchain or some other decentralized network.
Does that answer your question, Diego?
Yeah.
Okay.
All right. Thank you. Okay. Let me continue. Yeah, we also have the much larger device, like the smartphone, your wireless router, etc. So IoT device is a really wide range of device with different capabilities. So when you try to move the like the DID and VC framework, try to cover the different IoT devices, it definitely has some challenges. While the larger device might be able to directly run the your DID and VC framework, the smaller one, the medium one, definitely has some challenges. Yeah, challenge number two. The IoT device usually has a very complex device lifecycle you need to handle, right? So as we know, from the born of the IoT device until their end of life, it will go through very complex lifecycle, right? So for example, during the design phase, during design phase, the IoT device will be in the manufacturer's hands. You need to consider how the device should be provisioned, how to generate a identifier on your device. In the deploy phase, you need to consider how I can bring a number of IoT devices into my system, right? So in this phase, it involves how the network onboarding and the application onboarding, right? So how to bring the device into my own ecosystem, and how to make those devices running the application it is supposed to run. Yeah, after that, the device already being deployed in the field. The device will start operation, and you need to take care of the device management, device management, including like the over-the-air updates. You need to update the device firmware to give them the new features or fix the bugs you found when they are in the operation status. You may also need to consider to handle the ownership transfer when you transfer the device to other business units, to other people. Right? So until the end of life, that will be the decommission phase. In this phase, you need to think about how to decommission the device from your system, how to remove their credentials. So one IoT device goes through this complex life cycle. Each stage, there's many stakeholders involved, right? So like device manufacturer, system integrator, the application developer, system administrator, etc., etc. So all of those people, you need to clearly define their roles and which information they can access, right? So in this device entire life cycle. So yeah, definitely when you consider using the DID and VC in this concept, you need to clearly define the capability of the people and device in the different stage. Okay, you need to have a universal framework to handle the different services or different protocols that need to be applied in the device lifecycle. Okay. Third challenge is that, the IoT essentially they have unlimited use cases, right? So here just the IoT analytics, they summarize the top 10 IoT applications in 2020. You can see actually they cross all the industry domains, all the industry sectors for the IoT application. Each of the sectors, they might have their own special requirements. For example, the healthcare, you may have the more strong privacy requirements, or the energy field. You may also have some privacy requirements. Other field, you may need more strong security compared to other applications. So all of those IoT applications you need to be considered separately depending on which industry sector you work on, right? So, but they share some common components, definitely. But on top of that, you need to consider your own application. Those three just some major challenges when we consider applying the DID and VCs in the IoT context. We also have some other additional considerations, right? So first one, like what are the minimum requirements, hardware requirements for implement the SSI, self-sovereign identity for IoT, right? So a lot of projects have been created to implement this entire suite on the smartphone, right? So there you don't need to consider you do not have too much resource constraints, and you can take advantage of secure enclave on the latest smartphone for securely store the keys and your identity credentials, right? So, but for smaller embedded devices, what's the minimum hardware requirements, right? So you want to completely handle everything in software, or you may require your smaller embedded devices has a certain like hardware key storage or hardware accelerator for this purpose. Yeah, that's a first question. Yeah, you may need to consider. Second one, what do DIDs and VC eventually look like for the IoT devices, right? So W3C create a very complex and flexible standards for describing the DID and VC, right? So, but for the IoT device, do you need everything from standards, or you only need a constraint set that it will be enough for the IoT use cases, right? So those are also the other problem you may need to ask yourself. Third one, how can we implement efficient SSI SDK for the embedded devices? Already have several open source implementation in the community, which can be used in the much larger device like smartphone. But for smaller devices, how can we create a more efficient version in terms of the memory footprint and power consumption? Yeah, so especially for the battery operated embedded devices, that will be the essential problem you need to address. Fourth one, like how many DIDs does IoT device need in their lifetime? When we handle the people's identity, right? So you may need to change your DID frequently when you want to interact with the different services, right? So you try to protect your privacy. You try to create a service specific DID for certain interaction. But the IoT device, like all the existing system in the field, they don't change their identity during their lifetime. Yeah, many smaller devices they have a identity injected by the manufacturer or specified during their when they are born, right? So they usually do not change identity frequently in the application. Okay. Who is actually will issue the VCs in the IoT ecosystem, right? So we have many stakeholders. They can play the different roles in the ecosystem, but who is going to issue the VC and for which purpose? How should we deal with the privacy for IoT, right? So of course, not all the applications need to consider IoT applications need to consider privacy, but in the certain application scenario like healthcare or smart meter or some other location-based application, you may need to consider privacy. Those are all the specific questions we may need to consider when applying those concept DID and VC to the IoT domain.
Another question for you, Xinxin.
Yes.
The idea of presentation, verifiable presentation, or zero knowledge proof. How does that fit into the IoT construct?
So I think the idea is that verifiable presentation. The idea is you combine multiple verifiable credential together, right? So in that case, you still can prove to the verifier you actually have those several identity attributes without leaking extra information, right? So for IoT case, in some use cases, I think that principle still work, because you may receive multiple verifiable credentials from the device provider or from the operating system developer, right? So they will test the different attributes or the different aspect of your device, right? So your device has a, for example, you have TPM, which version, or you have the operating system, which version, right? So
okay, yeah,
that's a similar situation you might need to protect, right? So give you give you an example, right? So the like the TPM case, right? So the TPM 1.2, that might be that's be a good example. The privacy have been applied in practice, right? So they use direct anonymous attestation to say, okay, this attestation is came out from a group of TPM, but you don't need to know which one, right? So in this case, you don't they hide information about how many a particular device have generated a attestation report. That's just one example. But
okay,
in other more application-oriented use case, you need to think about which credential actually need in order to access which type of service, whether we need to create a verifiable presentation or not, right? So that's a zero knowledge proof. Definitely, it's more involved when you implement on the IoT devices, right? So you especially either RSA based signature or bilinear pairing based signature. The computation is expensive for smaller IoT devices.
yep.
It can be implemented definitely, but it's consume more computation resources and take more time to transmit.
Yeah, the other part would also be is that certainly currently within the SSI community, the ability to select which attributes are part of the presentation or part, when you get into a headless IoT device, becomes a different problem that would still need to be solved. I don't believe anyone has solved that yet.
Yes. I think that's need to be more clearly defined in the identity community, right? So for people that identity, I think that will be fine. You can have more flexible choices, but for IoT domain, the more fixed format is preferred. It's like like certificate, X4509 certificate even used in the IoT domain, all looks quite similar. They may have slightly modification, but the field is more fixed. Yeah.
Okay,
That's
thank
what I
you.
want to mention here. Okay. I think for addressing all those challenges, and will give us a new opportunity for developing decentralized IAM for IoT. I think the very nice direction is to you have something that's a decentralized IAM as a service, right? So this one could be replace the existing the centralized solution. Like decentralized solution, they bring a lot of advantages, right? In terms of the security, you can say, okay, now I remove the identity management part to a decentralized architecture. In this way you can immediately avoid the single point of failure. And the identity and ownership is quite important in the IoT domain, right? So everything you put in you add into your existing IoT system, try to protect the ownership. It's like who can control which device, right? That's the most important information. Once that information is hijacked, everything's gone, right? That's it. That's what you see in the news, like the home camera or your medical device have been hacked many times, right? So by moving this piece to the decentralized architecture, clearly advantage is a security enhancement, right? So other advantages in interoperability. Now you can eventually bring every device in your home together and control them in a universal way, right? So those are the all the very nice features when you consider when you consider bringing the DID and VC into IoT domain. And you can eventually break all the data silos in the different applications and make them work together to exchange value, to exchange the data. Also unlock the maybe some new business use cases which can take advantage of different IoT systems and build more larger scale application. Yeah, I think that's a great opportunity ahead for the entire identity community. To realize this vision, actually, we have some efforts from our side. One is this HVP 2958 standard projects. Yeah, this one has started early this year. We have already has a number of working group meetings already. I currently have a smaller it's a smaller working group with people from the big corporation, government research institute, and startups. It's a nice mix of people from the different entities. The scope for this project actually is to define a decentralized IAM for IoT based on the new concept like the DID and the VCs. Right? So this is the brief overview about this project. Regarding the focus, like I mentioned before, actually we try to integrate the DID and the VC into the IoT into life cycle of the IoT devices. More specifically, we will specify a suite of decentralized IoT security services. Like the authentication, authorization, access control, etc. So those security services it's going to use DID and VC to see how these two concepts can work. When it's being deployed to secure the entire life cycle. Essentially, we try to have the more complete picture to ensure the end-to-end security and trust for the IoT system. To identify, answer those some key questions. For example, where the device come from? It's come from a trust source. Is configured by the authorized personnel, or it's the connection has been authenticated or the encrypted. Which version or the OS operating system or application the device is running? Does the device operate as expected? All of those questions that need to be answered along the way.
Is this leveraging any of the IEEE SBOM, the software bill of materials? I mean, that would at least it would seem to be a place where something like a credential or some sort of a certain attribute around what the onboard software should be would make sense in your trusted software element.
Yeah, we may. There's some overlap with the different IEEE standards they are currently developing. We try to define a new set to see how this DID and VC can work. When you design the different those core services or protocols to conduct the lifecycle management. I think that's a main focus. This working group definitely the standard definitely related to other work. IEEE standardization other working group is doing, but it's the goal is to have a complete picture how this DID and VC can be applied here.
Okay.
This is just a preliminary table of contents. See which services we are trying to developing, right? So we will define the different function roles in the different stage. We'll consider device manufacturing, onboarding, maintenance, decommission, those key services. We identify those like the common services across all the different IoT applications. Yeah, that's why we try to work on these different pieces to give you a complete picture how this can be done in the decentralized version. Yeah, I see a number of questions. Okay, would it be impractical to achieve this scope using X509 certificate? Yeah, X509 certificate definitely it's quite popular to be used in the IoT domain. But the main use case for X509 certificate just to establish the TLS connections with a cloud IoT gateway, right? That's a major use case. It might be possible to still use X509 to implement this. Essentially, you can view X509 as a combination of DID and VC, right? So they have different fields to represent identifier, and you can also use the extension field in X509 certificate to add more identity attributes there. So it's X509 is a combination. I think it's from one perspective, it's like a combination for DID and VC. It might be possible, but the reason we consider the DID and VC here is that a lot of work have been done by the W3C community, by the other identity community, try to push this direction. It's like a lot of software, open source software have been developed, right? So to handle the identity of people. Yeah, when we consider device, it's better. It's better to consistent with this trend, right? So in that way, when the standard is deployed, which can directly interact with other software, which handling the people's identity. I think that's one consideration. Okay. Yeah. Last part, I would like to talk about some initiative on the IoTeX side. As I mentioned, I initiated a standard working group, more working on the specification and the standardization. However, meanwhile, we try to show actually what we have developed can be applied in practice as well. That's why in IoTeX we try to create an Internet of Trust Things platform, or the IoT platform for short. This our goal is to have the one-stop solution to show how this entire decentralized version can work in practice, right? That's why we build the hardware, in-house hardware, which will facilitate developer to do whatever customization or experimental you want to run. We have the Oracle to bring the data from your IoT device to the blockchain, right? Of course, we also have our own blockchain platform. So Ethereum, it's a EVM compatible platform. You can write your smart contract using Solidity. So we try to put every piece together. Then you can easily do all kinds of experiments to see whether it's really work or not. Then let's give you a brief overview about this. In terms of the hardware, we have this secure hardware called the Pebble Tracker. This one is actually it's out of box, trusted and secure asset tracking development kit with 4G connectivity and a wide range of sensors on board. Okay, this one is built around the latest low power NRF 9160 system in package chip from the Nordic Semiconductor. It's our industry partner. On this device, we already equipped it with GPS, climate, motion, and light sensors, which means you can collect more than 10 dimension of data from your environment. More importantly, this device is a system on chip platform with very strong security supported by the ARM trust zone and the crypto cell 310. It's also ARM technology for security subsystems. This one you can they support LTM or NB-IoT, can be operated globally with IoT SIM card. Very nice thing about this hardware platform is all the development tools, SDKs, are open sourced from the Nordic Semiconductor and from IoTeX. We did further customization based on the SDK from the Nordic, and add some features you might need to talk with blockchain. Okay. A little bit more information about this. This one it's a smaller, maybe it's a medium microprocessor running the Cortex M33. This one supporting the ARM trust zone. Then you can isolate your application to secure world and normal world, and you can secure your key storage and use a crypto accelerator on this device to do key generation, digital signature. If you want to wrap up a smaller SDK for the DID and VC is also doable. And a bunch of sensors on board, and Nordic Semiconductor has a very short technical perspective about how you can use this for the secure asset tracking. Okay. Most importantly, this one is also a community-driven hardware. We launched this on the crowd supply, it's a crowdfunding platform to see how many developers will be interested in using this. So far, it looks promising. We have more than 400 backers. They want to try this. They want to try this device and do further customization and development. And this paper tracker is currently in massive production. Will be released to the community very soon. This is a hardware piece we created. Essentially, if you want to port a SSI SDK into this smaller device, I think it's highly doable. You can see, you can take advantage of all the security hardware features on this device to store the key, to generate the DID and VCs here.
If you were going to build an SDK, what languages are you talking about? That C, Rust?
This one you still use C. This the Nordic SDK is running in C, and it's running on the Zephyr OS. It's another open source real-time operating systems. Okay. That's mainly supported. We build another additional features about their SDK. To show how this one can be used in the blockchain world. Okay.
There is a question in the chat about 4G versus 5G.
5G, I don't know there's whether there's a 5G IoT chip in the market yet. There's a 5G phone, but that is a chip using in the smartphone but IoT chip might be used. Might need to be wait for a little bit more time. But it's just still iteration. Based on what they have so far. In terms of the security, 5G just give you another way to establish communication. But they bring the advantage like the throughput, communication latency. It's not directly related to the DID, right? So or VC. It will help you to establish or talk with the other entities much faster, and you may be able to streaming the data fast in the 5G use case, but it's not so directly related to the DID and the VC. Just provide you more options in terms of the connectivity. This pretty much about the open source hardware we are going to release to the community. Actually, you can place around to explore the Actually, it's a very nice platform. You want to port the SSI, SDK or libraries to here to try. Second piece, we also need an Oracle, right? So we have the device on the physical world. We need to empower the machine-based economy. The only way is to you bring your data on the physical world to the blockchain. That's why we need an Oracle. But we build this so-called true stream decentralized blockchain Oracle. Firstly, it's an Oracle, like all the other Oracle in the blockchain community. They are doing just single thing, bring something from the physical world to the blockchain. But the TrueStream Oracle is also different in the in the aspect that this Oracle is more IoT focused. It's a decentralized Oracle, meaning that we have the multiple Oracle nodes running this protocol, right? So on the left side, we have the IoT device. They will tell the Oracle what those device has been done, right? So they may they may collect the data to send the data, or they may complete some activities. For example, they access certain website, or they monitor an event, right? So all of those different data, events, tasks will be those will be recorded on the IoT device. They will generate a proof, or they may send those data to show actually I completed this task, right? So on the TrueStream node side, you can see each TrueStream node actually is they provide the computing capability, storage capability, also connectivity. This connectivity will support different popular IoT communication protocol like MQTT or CoAP, HTTP, HTTPS, etc. So they are able to talk with more different type of IoT devices, right? So once they receive this proof from the device to say what they have been done in the physical world, they will run some kind of a consensus process, then generate another proof called TrueStream proof. This proof can be understood by the smart contract on the blockchain. Right? So this basically give you a high-level idea how this Oracle work and how it's different from the existing Oracle you have been seeing in the blockchain community. Many Oracles just grab the data from the third-party APIs, but this one is really combining the IoT gateway functionality with blockchain capability to bring something happening in the physical world conducted by the IoT device into the blockchain world. So on the blockchain side, you can do all kinds of DApp development to take advantage of what's happening in the physical world. Then you can build the DApp to trigger machine-based economy. That's how this Oracle works. Stay tuned for more technical technical aspect in the next few months, we are going to release more details about this. Yeah, in terms of the interaction with people, we have this IoT portal. Actually, you can add your device into here and check out the device status. And there's an app store here. Essentially, if you are an embedded developer, you can deploy a specific the embedded application on this store. This application will be can be downloaded into the certain IoT device. You can download into the for example, the Pebble tracker or Raspberry Pi Arduino board. Depending on your feature of your app, right? They will do something and go through the TrueStream node. What they have been done will be bring to the blockchain world. You can interact with this with portal to they will have show your dashboard, the data that have been collecting, also to show your data has goes to the blockchain to interact with certain DApp. That's a few pieces we put together. Try to build a decentralized IAM to see how it can be worked in practice. I think that's all I want to share today. If you have more questions or want to discuss more, we can continue our discussion.
Thank you, Xinxin. This is a very interesting presentation. Does anybody have any additional questions? A lot of information. Okay, I think that people are absorbing it all. Will you make can you send me the slide deck? Are you okay with sharing the slide deck?
Sure.
Yeah, okay. Like I said, I am recording this. The recording will be up probably by the end of the week or early next week at the latest. If there's no other questions for Xinxin, give people a going once, going twice, 3 times. Thank you. If you let me just stop sharing your screen, I'll share a couple more things on what's coming up.
Michael, I just had one quick thing to throw out.
Sure.
I'd love to see collaboration between the respective IEEE groups because Dr. Fan, I'm a big fan of your paper and have referenced it for presentations of my own around SSI and IoT, especially around zero trust architecture. And I think the things that we're doing in 2933, Michael, relate back to governance framework considerations for what they're doing in Dr. Fan's group.
I would agree, Jim. I think that there's a lot of stuff, and I certainly have questions around or thoughts around, device registries as in decentralized IAM versus medical device registries, which are similar yet very different worlds, because their ultimate objective is very different compared to access control. So I think that there's some very interesting things on potentially working together or certainly communicating. And I think that's one of the things that when we do speak fairly frequently or fairly regularly, that's some of the things that we do share back and forth. Where we are allowed to by maintaining IEEE's rules. I will say. So
got to play nice in the sandbox. I hear you.
Yep. Got to follow the rules. So coming up next week, if people aren't aware, IAW is next week. It is virtual again. I don't remember. It's either 33 or 35. I forget which number. If you are not familiar with the Internet Identity Workshop, it's definitely worth doing a bit of a poke around, just Googling that and looking at it. It is a workshop, it's an unconference. It will make your head explode. with some of the conversations in detail that gets discussed there. Xinxin is talking about, SSI, DIDs and credentials. This is where a lot of this, the basic technology has come out of. So it's some very sharp people, very broadly attended, and it's certainly worth the investment of time. Also coming up next week is a OIX Open Identity Exchange Identity Trust Conference in London. And then the week following, Identity North, which is another big identity conference based out of Canada, is having a virtual fall symposium. So for folks who are unable or not that a little bit concerned about getting in airplanes these days, all of certainly IIW and Identity North are virtual events so that they can be attended from wherever you are sitting. End of the month, the fourth Monday, will be the 28th meetup. Mathieu Glaude from Northern Block will be presenting. We'll be announcing that shortly. Then the beginning of November, Mirnal Vadha, CTO from Occam, will be presenting as well. So we'll continue on the IoT thing. Other than that, I thank you for your participation. Have a great evening, day, or morning, wherever you are. And I will hopefully see you at a future event. Thank you.
Thank you.